With the help of the Subdivision Surface Modifier, we can add a lot of geometry very quickly to any object, whilst also being able to smooth out the topology of our models to create a more natural, cohesive appearance. To access the Subdivision Surface Modifier, go to the Modifiers tab in the Properties panel. Select the Add Modifier button, go to Generate, and from here choose Subdivision Surface. This will add the Subdivision Surface Modifier to the existing object. The effect that Subdivision Surface has on any object is apparent, especially one that has initially sharp edges. Let's take a look at the Subdivision Surface Modifier on a couple of other different objects, such as, first of all, the UV sphere. So this is already very spherical. You can see that when we applied or added Subdivision Surface to our initial cube object, it started to become more spherical itself, almost like a ball. But the UV sphere is already quite spherical. If we add Subdivision Surface, we add a lot of geometry to the UV sphere, but we don't change its shape too much. This is because when using Subdivision Surface by its default method, not only are you dramatically increasing the amount of geometry, but you're also creating a smoother appearance, and Subdivision Surface, where possible, is going to try to turn your object into a ball unless the geometry simply doesn't allow for it. Let's take a look at another example. This time we'll try an icosphere, which uses three-sided faces primarily as a part of its construction. So Subdivision Surface actually works very well with four-sided faces in particular, which the cube and UV sphere both possess. But the icosphere only uses three-sided faces. If we go with Subdivision Surface, you can see that we are still perfectly capable of creating that new geometry from the existing model, but the pattern is going to look quite different because we were using triangles beforehand, whereas with other models we typically use quads for the most part. Two quick examples more. First of all, the cylinder, which has a little bit more of a distinctive shape than the other models. So if we use Subdivision Surface here, again, you can see the impact that it has on our object. Doesn't even look like a cylinder now. And of course you can increase these levels if you want, and it's starting to actually look a little bit like an onion. So we've gone from a cylinder to an onion just by using Subdivision Surface very quickly. And the last option I want to show you is Suzanne the monkey. Now this has a much more complex structure than any of the previous objects, so it's a good idea to get an impression of how Subdivision Surface would impact such a model. So we're going to add it to Suzanne, and you can see it just smooths out a lot of the jagged edges that you would see on Suzanne initially, and just gives it a much cleaner appearance. So Subdivision Surface has a ton of different use cases and can be applied to almost any mesh object. Let's see what happens if we were to apply the geometry created using the Subdivision Surface Modifier. Before I do that, I want to make a note of what we can do with objects in edit mode. So here in edit mode, initially, we'll have the ability to select the geometry as it was before we added Subdivision Surface. And this is not just the case with the cube object, it's the case with the other models as well. So with the cylinder, we can go into edit mode and you can see all of the original geometry. We can manipulate this geometry however we want as well, which is going to change the effect that Subdivision Surface is going to have on said geometry. For now, I'm just going to use Ctrl-Z just to bring us back to the original state. And you can also change the way in which your geometry appears in edit mode by clicking on this option right here. This is the cage option, and while it's present on many of the different modifiers that you can use, it is most useful with Subdivision Surface. So I'm just going to go into edit mode, and then I'm going to turn this option on. You will now see that the cage or the mesh now sticks to the generated geometry of the Subdivision Surface Modifier. We can still select any of this geometry and manipulate it however we want, but we're now doing so with a slightly different perspective on exactly how that geometry is going to be affecting our object. I'm going to turn this option off, and now let's apply the Subdivision Surface Modifier. So left click on the arrow icon and then choose Apply. Now we're going to hit Tab to move into edit mode, and this time I'm able to select all of the individual faces that were created using the Subdivision Surface Modifier. Let's repeat this process with the UV sphere. So we'll apply the modifier, press Tab, and then you'll be able to select all of the geometry that the modifier created. And the same is true with any object regardless of the shape and structure. Here the icosphere has a very different structure, but we're still now able to select any of the faces generated using Subdivision Surface. Again, with the cylinder object, we have a very strange looking model here, but that doesn't mean we can't go into edit mode and manipulate any of these faces however we see fit. Lastly, let's quickly apply the Subdivision Surface Modifier to Suzanne, and once again we have all of this new geometry that we can play with using a variety of different tools such as extrusions, bevels, insets, or even other modifiers. Speaking of which, let's take a look at how we can use Subdivision Surface with other modifiers in the Properties panel. So here I have my cube object. It's just a default cube again, and let's add Subdivision Surface first of all to generate new geometry. Now if we return to this menu, there are a lot of modifiers here that can work pretty well in combination with Subdivision Surface. For example, we have the wireframe modifier at the bottom. The idea here is that the wireframe modifier generates a wide mesh from the existing model. When used after the Subdivision Surface modifier, it's going to create a wireframe out of not only the original geometry, but also the geometry created as a result of Subdivision Surface. However, what if we were to change the order of the modifier stack? So I can click and drag to move wireframe above Subdivision Surface. This creates a very different result, where we created the initial wireframe from the cube object, and then we use Subdivision Surface on the wireframe itself. So in one example, we subdivided the original mesh and then created a wireframe from that. In the second example, we created a wireframe and then we subdivided that wireframe, and that's because of the order that we've placed these modifiers in the Properties panel. Another example of a modifier that may work well with Subdivision Surface is the Bevel modifier. Here, we're effectively taking the Bevel modifier and creating additional segments of geometry around our model after we have subdivided it. But what if we wanted to maintain the shape of the cube better? Well, we can use the Bevel modifier before Subdivision Surface, and this to a large extent maintains the shape of the cube. We can then manipulate some of the parameters such as the amount value, which I could perhaps set to 0.01. Actually, let's go even lower, so 0.002. And potentially increase the number of segments. And as I do that, you'll see that the effect actually changes very quickly. So let's go back to 0.01. And here we're effectively beveling the geometry first at the corners, and then we're subdividing it to add a lot more detail, even at a granular level, around the edges of our cube. And you can actually see how the light starts to catch on these edges, because we've first of all beveled them, and then we've significantly increased the geometry by using the Subdivision Surface Modifier. The most important thing to remember when using the Subdivision Surface Modifier is that when the Subdivision Surface Modifier is active, the number of viewport levels can differ from the number of render levels. However, this will change when the modifier is applied. So for example, here we have viewport levels set to 1, render levels set to 3. We can see in the 3D viewport how much geometry currently exists on the model. But let's render the image and check the result. The resulting model has a lot more geometry because it's using the render value in the Subdivision Surface Modifier. This is probably the key reason to use Subdivision Surface. You can define a lower viewport level in the 3D viewport while editing, and then you can render out using the higher value. If we were to apply, however, which of these two values do you think is going to be maintained? Let's go and apply Subdivision Surface, and it looks as though we are still using the levels of the viewport subdivision rather than the render. Now if we go to render and render image, you can see again we are using what was the level for the 3D viewport, and now that has been applied to the render. So keep in mind, when you apply Subdivision Surface, it's going to use the value of the viewport levels and not the render levels. When working with the Subdivision Surface Modifier, there are two methods that you can choose. I'm going to replace this model with a fresh cube and add the Subdivision Surface Modifier. Up to this point, we've been using Catmull-Clark, but we also have a simple method for using Subdivision Surface as well. The key difference between Catmull-Clark and simple is the fact that with Catmull-Clark we not only subdivide the geometry, we also smooth out the vertex coordinates. This creates a smoother, more spherical appearance for almost any object shape. It's best used if you want to create a more organic shape that doesn't have sharp edges. By contrast, simple only subdivides the geometry. This means it's actually difficult to see initially in object mode while the Subdivision Surface Modifier is active, but these values here for viewport levels and render levels still do exactly the same thing in terms of increasing the amount of geometry. If we were to apply this Subdivision Surface Modifier using the simple method with our viewport levels set to 2, and then move into edit mode, you would be able to see that we have indeed been able to subdivide the model. Again, the key difference here is that with the simple method, we only subdivide it, but we do not relax the vertex coordinates to create the smoothing effect that you would normally see with the Catmull-Clark method. A key tip when using Subdivision Surface, regardless of your method, is to be cautious when increasing the number of levels for your subdivision. Even using a basic cube as the starting point, if we were to increase the number of subdivisions up to even as high as 6, it would create a substantial amount of geometry for our model. Down in the bottom corner, I have enabled the scene statistics, which allows us to determine the selected object's collection, name, number of vertices, number of faces, number of triangles, objects in the scene, and current version. You can see that we have over 24,000 faces currently active on our model. and this is just for a single object. If I reduce the levels in the viewport all the way back down to 0, you can see we start with 6 faces. Increase this value and we multiply the number of faces by 4. Increase it to 2, 3, 4, and so on, and we continue to increase the amount of geometry on our model. If I apply the Subdivision Surface Modifier with the viewport levels set to 6 and then press the Tab key, we actually have to zoom in if we want to select any of our geometry. And the important thing to remember here is that this was using a single cube object. There are very, very few objects that you can make in Blender that would have a fewer number of faces than a cube. So for any more complex models like characters, for example, which will already have a significantly higher number of faces, you would have to be very cautious when it comes to increasing the level count for the 3D viewport. In fact, let me just show you an example with a slightly more complex model. So I'm going to delete that object and bring in Suzanne the monkey. Here we're starting off with around 500 faces, compared to the cube which only had 6. Let's add Subdivision Surface, and just by selecting our model here with one viewport level, we've increased to almost 2,000 faces. Level 2, and I'll need to just left click just so it updates, brings it up to close to 8,000, so on and so on. So here we're only on 5 levels in the viewport, but we're using 500,000 faces. Now at the moment, if I click and drag, performance is pretty good, but this is dependent on the device that you are using. I have a relatively decent computer to work with, so it's not that much of a problem in the 3D viewport when it comes to orbiting around my scene. If I increase this to 6, you might have noticed there was a tiny bit of lag there as we increase the number of faces to 2 million. And again, for me, it's not too bad. But keep in mind that if I was to go and apply this and then go into edit mode, you can see just how long it took there to go into edit mode. It took about 2 seconds, and every action now just takes a little bit more time to actually function. So here I click and I have to wait about half a second for the geometry to be selected. So again, keep in mind that the more geometry that you add, the more viewport levels you add to your model, the more detail you'll create, but the more at risk you'll be of lag or even potentially in some cases crashing your project in Blender. Beyond the standard properties that we have in the Subdivision Surface Modifier, there are other tools that we can use to influence how Subdivision Surface affects our model. One such tool is the ability to crease our edges and faces. Creasing uses a numerical value that can help to determine how much influence the Subdivision Surface Modifier can have on a specific edge. Here I've got a cube that has been subdivided 3 times. I'm going to go into edit mode for this model, and I'm going to open up the side panel. From here, I'm going to come down to where it says Edge Data, and there's a value here labelled as Mean Crease. Watch what happens to the geometry as I increase this value. So click and drag, and you'll see once I hit to a value of 1, it actually flattens out that entire side of the cube. I could do the same with the face on the other side of our object. So select it, increase the mean crease value. And just like that, we've used Subdivision Surface to transform our cube object into an actual cylinder. All we would need to do from here is just apply the Subdivision Surface Modifier in object mode, and we'd have our cylinder object. But you don't have to select an entire face for this to work. You can just select a single edge, go to the side panel and increase the crease value, as it would then be called because it's a single edge rather than multiple edges. Click and drag, and you would be able to influence how the subdivision surface modifier affects that singular edge using a range of 0, which is full influence of subdivision surface, to a value of 1, which is no influence of subdivision surface on that edge. If we select all of our geometry at this point, we'll get a mean crease value, and it won't be set to 1 because some of our edges will be set to 1 while others will be set to 0. So this value is quite simply the mean crease value of all of the selected geometry. I'm just going to reduce this back to 0 because there is a similar value that we can manipulate, and that's the mean vertex crease. The difference between the two is that the edge version of this parameter is going to affect the geometry from one vertex all the way to the next and all of the geometry in between. However, the vertex crease is designed to work with the vertices related to the corners of our model specifically. So if I was to actually select everything and increase the vertex crease value, we'd actually end up with a very pointy effect, as the vertices that resemble the corners of the cube would be branched out all the way to the edge of the original shape. If I was to reduce this back down to 0, and then create a similar example to what we had before, where we used the mean crease, I can use the vertex crease instead, and you can see how this differentiates from the mean crease. So we can create two very different shapes by manipulating these two crease values. And we can also do both of them at the same time if we want to. So we can bring the vertex crease up to 1, and then we can increase the mean crease value to however far we need it to go to create our ideal shape. In addition to the base settings, we also have some more advanced parameters that we can manipulate. For example, we have a checkbox here for use creases. Now we've just covered how we can define crease values for specific edges, but we can turn on and off this functionality entirely from the advanced section. So for example, let's say I was to increase the mean crease value of these edges. We can set this all the way to 1, and you can see the effect it has on the model. However, if I was to turn this option off, which is typically on by default, it will ignore any crease values that we manipulate in edit mode, both for the edges as well as for the individual vertices. Going back to the top of this section, we have a tick box called Use Limit Surface. Now what this basically means is that when Subdivision Surface Modifier is placing the new vertices on your geometry, by having this box ticked, it's going to do so in a way that maintains both the smoothest possible shape, but also means that you can continue to subdivide the mesh after the fact almost indefinitely. So the newly created subdivisions are always going to be in a unique position when you have this option ticked, but it's going to be in a position that allows for the best possible results. What this also means is that this can be a relatively resource intensive option. Even though it is ticked by default, you can untick this option, and you see here it creates a very subtle change on our model, and it will create a slightly inaccurate result depending on the complexity of the model itself. But in a lot of cases, it actually doesn't matter too much whether you have it ticked or not. The only difference in this example is the appearance or the size of the model seems to shift because the vertices are not specifically positioned with this unticked to create the smoothest result. quality is directly tied to the use limit surface property. When we adjust the quality value, which ranges typically between 6 and 1, this defines just how effective the use limit surface option is going to be at placing your vertices. With the quality set to 1, at the moment we can see the positioning of our vertices. Pay attention to the one here in particular, and as we increase the quality, you can see that the actual edges that are created are smoother as we increase that quality value. Once we get to 3 though, that seems to be the limit with this model, and keep in mind it is a very simple model. As we increase the quality further, there's no visual difference. So normally you wouldn't actually increase the quality value here unless working with a very complex model where the geometry is likely to be very close together with a very high subdivision value. That would be the use case for increasing the quality value here to prevent any geometry from potentially overlapping. We then have UV smoothing. So this is going to affect the UV map of the model after subdivision surface has been applied. We have a series of options here ranging from all to none. The default one is to keep the boundaries. What I'm going to do is I'm going to go to the UV editing workspace, and here's what we can see on our UV map when the entire model is selected. Now I'm going to go into object mode, and with UV smoothing set to keep boundaries, let's see what happens if we apply subdivision surface. We're going to select the model, return to the UV map in edit mode, and you can see all of the geometry that has been added in edit mode. So this is perfect, but what happens if we were to change that UV smooth option? I'm going to hit Ctrl-Z a few times until I return to the UV map in edit mode again. And this time I'm going to change from keep boundaries to all. Now I'm going to apply subdivision surface once again, select the model and hit tab to go into edit mode. You can see that this has now smoothed out the geometry of the boundaries for our UV map. So the shape has now changed considerably. This will also change the way in which the texture is going to be applied to your model. There may be some instances where you would want this to occur. However, the reason why the keep boundaries option is ticked by default, if we were to just go back with UV smoothing and go keep boundaries, the reason why this is the default option is this tends to offer the best results for any object in which you create a UV map for. Here we have Suzanne, a slightly more complex mesh, and if we keep the UV smooth to keep boundaries, we can move into edit mode and preview the model. Again, keep in mind the boundaries are the edges that separate the different islands of the UV mesh. So if we keep the boundaries, when we apply this modifier, we'll subdivide all of the geometry, but the shape of the UV map's islands will remain the same. So let's, I just deleted that by accident. Let's apply subdivision surface, then return to edit mode, and you can see here that the sharp edges of each island have been maintained on this mesh. Now this is a very smooth mesh, so perhaps you might want a smoother UV map. In this case, you would go with the UV smooth option for all, which is going to include the boundaries for the UV smoothing when the modifier is applied. So here we're going to apply subdivision surface, hit tab, and this time you can see there's a nice curvature going around each island as the smoothing has now been applied not only to the geometry within each island, but also the geometry that creates the boundaries of that island in your UV map. We then have the boundaries of the model itself. Now the boundary is effectively any edge that does not have a face either side of that edge. So here we have a plane that has been extruded up and beveled. If we go into edit mode, we have the faces for the bevel. So here we have these individual faces, and the boundary of these faces is going to be this edge and this edge. But for the end faces, we also have additional edges which act as the boundaries. So any edge where there's a face on one side but no face on the other is going to typically be a boundary for the model. If we add the Subdivision Surface Modifier to this example and open up the advanced settings, we have the Boundary Smooth property. By default, this is set to all, which means it's going to smooth all of our geometry, including the edges used to make the boundaries. If you want to remove this, you can just choose the Keep Corners option. This will apply smoothing to your geometry as normal, but it will exclude any edges that are classed as boundary edges. In other words, if an edge has only one face on one side but no face on the other, it's going to be maintained because it's classed as a boundary by the Subdivision Surface Modifier. The final option for the Subdivision Surface Modifier is to use custom normals. We can edit the normal direction of individual faces and vertices in any number of ways using Blender. Subdivision Surface isn't going to take into account these changes, however, unless you tick the option for Use Custom Normals. For example, we have our plane here that has been subdivided, but we can clearly see the intersections where the bevel occurs. The shading is very different with the curved surface compared to the flat surfaces either side. Here we're going to go into edit mode for the model, go to the mesh menu and go to normals. There are many different ways in which we can manipulate the normal directions. I'm going to go with a simple option which is set from faces. I might as well choose the Keep Sharp Edges option, and then if I go back into object mode, you'll see that very little change has occurred. Again, as we said earlier, Subdivision Surface is not taking into account changes made to normal direction, unless you tick this option here. So left click and you should see a subtle yet significant change in the shading, especially where the flat surface meets the curved one. So this is before and this is after. It might be difficult to see on your screen through a video, so I do advise that you copy this example in Blender yourself, just to ensure that you can see the difference in shading when we use this custom normals value. That wraps up how we can use the Subdivision Surface Modifier in Blender. If you enjoyed this video, don't forget to like, subscribe and hit the notifications bell icon for future updates and tutorials with Blender. If you want to support us, we have a link to our Patreon in the description as well. But for now, that's all from me, and I'll see you in the next one.